If you carry type O positive blood, your cells are quietly broadcasting a message that shaped human survival for thousands of years. But modern medicine has only recently learned how to understand what that message actually says. For decades, blood type was treated like an administrative category, a practical detail scribbled on hospital charts to prevent transfusion accidents. But the moment researchers could decode the genetic secrets buried inside those simple letters, they discovered something that completely changed our understanding of your health, your risks, and why your body was built the way it is. The latest research into how your blood type influences everything from heart disease to blood clots reveals a fascinating paradox at the center of your biology. You were given genetic tools that protected your ancestors from some of the most lethal invisible enemies they ever faced. But those same protective mechanisms come with a hidden cost in the modern world. To understand this trade-off, we have to travel back to the discovery that started it all. In the early 1900s, a curious researcher named Karl Landsteiner was investigating a deadly mystery that haunted every hospital in Europe and America. Blood transfusions were essentially a gamble with people's lives. Sometimes they saved patients, sometimes they triggered violent, fatal reactions that doctors couldn't predict or prevent. Landsteiner noticed something remarkable under his microscope. When he combined certain blood samples, they remained uniform and smooth, but when he mixed others, they would suddenly clump together in thick, sticky masses. He had just uncovered the secret that blood groups existed, and that discovery earned him the Nobel Prize. But in celebrating this breakthrough, the medical establishment made an assumption that would echo through the 20th century. European scientists looked around at their own populations and noticed that type A blood was prevalent, so they concluded that type A must be the ancestral form of human blood, the original design. Type O seemed like a later mutation, a variation that came later, but research would eventually prove this completely wrong. Decades later, when molecular biologists finally developed the technology to peer inside the chromosome and map the ABO gene, they found something unexpected. The gene sits on chromosome 9, and it acts like an instruction manual, directing your cells to produce specific molecules on their surface. These molecules are called antigens, and they're the reason blood types exist. When geneticists began comparing this gene across populations around the globe, the patterns they discovered were absolutely remarkable. In Europe, yes, type A was common. In parts of South Asia, type B reached surprisingly high frequencies. But when scientists examined indigenous groups in the Americas, people whose bloodlines had been separated from the rest of the world for tens of thousands of years, type O appeared at staggering levels. Some native populations showed nearly universal type O blood, with almost every single individual carrying it. In genetics, this is never random. This is a founder effect, meaning the original small group of settlers who first arrived in the Americas possessed overwhelming quantities of type O blood, and they passed it down to every single descendant that followed. Where did these early settlers come from? Every piece of evidence, from ancient skeletal remains to the study of mitochondrial DNA, points back to Asia. These explorers crossed a frozen landmass that once connected present-day Russia to Alaska, pushing through brutal Arctic conditions, carrying their type O blood signature across an ocean of ice. Today, you can still trace this genetic inheritance. Parts of Asia carry tremendous reserves of type O genetics. In Southeast Asia, around 4 in 10 people carry this blood type. Yet across Asian populations, you can find every blood type, meaning type O is not exclusively Asian but deeply rooted there. When scientists examine the genetic markers that surround the O allele in people worldwide, those markers form a trail that leads directly backward into the ancient civilizations and peoples of the Asian continent. But this raises a critical question. Why did type O become so common among populations that ventured into new environments? Why did natural selection favor it so powerfully? The answer has nothing to do with climate or physical dangers. It has everything to do with microscopic enemies. Throughout human history, the deadliest threats were not wild animals or harsh winters. They were invisible predators, infections caused by bacteria, viruses, and parasites that annihilated entire populations. And your blood type is the arena where these silent wars were fought. Consider malaria, which has killed more humans than any other single disease in history. The parasite that causes malaria invades red blood cells and multiplies there. But here is where type O becomes unusual. The cells of type O individuals lack certain surface structures that the parasite desperately needs. When malaria attempts to infect these cells, they simply do not stick together the way infected cells normally do. The normal cascade of cellular sticking and clustering never happens, and the parasite's strategy collapses. Studies have documented that type O carriers have substantially better survival rates during severe malaria infections, allowing them to recover and pass on their genes. Over thousands of years, in environments where malaria killed populations relentlessly, this protection became a profound advantage. Now consider norovirus, the stomach virus that sweeps through communities and cruise ships with frightening speed each winter. The virus is highly contagious and causes severe gastrointestinal distress in millions annually. But norovirus cannot simply infect anyone. To penetrate digestive cells, the virus must latch onto specific molecular patterns found primarily in blood types A and B. Type O blood lacks these attachment points entirely. The virus cannot unlock the door to your cells. During major outbreaks, researchers have tracked individuals with type O blood who were directly exposed to the virus in their households and communities, yet they remained completely symptom-free while everyone around them became violently ill. This protection is extraordinary. Across thousands of years of human history, carrying a blood type that automatically resists two of the most devastating epidemic diseases you could encounter is not merely luck. It is an evolutionary gift. And it explains precisely why the populations that expanded from ancient Asia into tropical disease-heavy regions, into the Pacific Islands, into the Americas, disproportionately carried type O blood. They did not consciously choose it. They simply survived epidemics that might have wiped out other groups, and their blood type became the legacy. But evolution always demands a price. The same cellular smoothness that saved type O ancestors from malaria and stomach viruses creates different vulnerabilities. Cholera is a perfect example. In regions where cholera has been an historical scourge, like the Ganges Delta in India, the disease behaves very differently depending on blood type. The cholera toxin binds far more readily to the cells of type O individuals. When an outbreak strikes, type O people suffer more severe, more life-threatening dehydration than anyone else. This is not random. It is natural selection still writing its story in real time. The populations of India, where cholera has been endemic for centuries, show lower frequencies of type O blood, exactly because the disease has been steadily selecting against it. The environment literally shaped the blood type composition of its people. Then there is your digestive tract. If you have type O blood, you have a meaningfully elevated lifetime risk of developing ulcers in your stomach. This is because of a specific bacterium shaped like a corkscrew called Helicobacter pylori. This particular microbe thrives in the stomach environment of type O individuals. It burrows into the protective mucus layer and triggers inflammation that eventually damages the tissue. In East Asian populations where this bacterium is common, researchers have documented higher rates of stomach ulcers and cancer risk in type O carriers. And if you want a small but genuine annoyance, mosquitoes actually prefer you. In controlled experiments where volunteers placed their arms inside containers full of hungry mosquitoes, type O blood carriers were bitten nearly twice as frequently as type A carriers. Your blood chemistry literally makes you more attractive as a meal. So type O positive is not simply good or bad. It is a complex inheritance, a masterpiece of evolutionary balancing where the benefits are real, but the drawbacks are also genuine. But just as scientists felt they had the entire type O picture mapped out, something unexpected emerged. In 1952, a patient arrived at a hospital in Bombay asking for a transfusion. The testing showed type O blood, so they received a standard type O transfusion, but their body rejected it violently. The doctors were baffled. How could type O reject type O? When researchers investigated further, they found something remarkable. Think of blood type antigens as layers on top of a base. Types A and B are the top layers. Type O seems to be just the basic layer, made of a precursor molecule called the H antigen. But this patient had something even more fundamental missing. They lacked the H antigen entirely. They looked like type O because they had no A or B layer, but the foundation was completely different. This condition became known as the Bombay phenotype. It is a genetic anomaly that medical science still does not fully understand. Individuals with this phenotype can only receive blood from other Bombay donors, nobody else. It is remarkably rare in most of the world, but in South Asia it appears more frequently, showing up in about 1 in 10,000 people. The Bombay phenotype is a window into how deeply human blood type diversity runs and how ancient populations developed unique genetic variations that standard medical categories fail to capture. When you step back and look at the complete arc of human history, the story of type O blood is genuinely epic. Thousands of years ago, after the Ice Age had ended and the continents had separated, seafaring explorers from what is now Taiwan ventured into the vast Pacific Ocean in outrigger canoes. They were driven by curiosity or survival pressure to explore unknown waters. They discovered Hawaii far out in the ocean. They found New Zealand. They reached Easter Island. Everywhere these Polynesian voyagers landed, modern genetic testing reveals staggeringly high frequencies of type O blood. Two of the most isolated human civilizations on the planet, the indigenous peoples of the Americas and the Polynesian cultures scattered across the Pacific Ocean, are separated by an impossible distance and an entire ocean. Yet they both carry the exact same ancient Asian genetic signature in their blood. The ocean did not erase their inheritance. It carried it across the world. In modern times, science is revealing new details about how your type O blood continues to influence your daily health. We now know that type O carriers have blood that flows just slightly thinner than other blood types. Your plasma contains lower concentrations of certain proteins that make blood clot, particularly a protein called von Willebrand factor. This means you have a statistically lower risk of developing dangerous blood clots in your deep veins or suffering from blockages in your arteries. Your cardiovascular risk profile is genuinely improved compared to people with type A or B blood. But this protection comes with its own consequence. If you suffer a serious cut or wound, your bleeding time is actually slightly longer. Your body takes a bit more time to form that critical clot that stops the bleeding. Every single trait is an echo of a challenge your ancestors had to survive. Fast forward to today, living in a modern world with antibiotics, hospitals, and clean water. What does your type O blood actually mean for your life right now? That letter and plus sign on your medical record is not just a technical category. It is a survival achievement forged across tens of thousands of years. It means that somewhere in your distant ancestry, your family walked through the river valleys and tundra and tropical forests of ancient Asia. They faced microscopic killers that reduced populations to fragments. They stood at the edge of extinction from plagues and fevers, but they survived. Their cells adapted. Their blood carried a signature that protected them from the deadliest diseases of their time. They crossed oceans. They discovered new lands. They endured and multiplied. And they passed that exact biological inheritance to you, generation after generation across centuries. You are the living proof of their victory. Your blood carries the story of the oldest human journeys ever taken, and science is finally learning to read that story written in your cells. If this exploration of what your blood type reveals about your hidden history resonates with you, I want to hear about it. Drop a comment below and tell me what you have discovered about your own blood type and what that means to your family's story. Thank you for joining me on this journey through the genetic memory of humanity. Stay curious.